Welcome to Delgado Community College, Math 120, Chapter 3.1, Logic Statements. This video is not intended to be a substitute for reading the book, but as a supplement to the book. Upon completion of this section, you should understand the following concepts. Define and identify statements, define the logical connectives, write the negation of a statement, write statements symbolically. At times, you should pause the video and try to answer the problem, then restart the video. A simple statement is a declarative statement expressing a single idea that can be objectively determined to be true or false. So, a simple statement is a sentence expressing a single idea. And that statement is either true or false, meaning objectively. There's no bias or whatever in the determination if something is true or false. We're not concerned whether or not it is true or it is false, just the mere fact that it is either one or the other. So let's identify which of the following are simple statements. Pause the video, answer it, then play the video. Nikki is a student in vet school. Well, this is a single idea that Nikki is a student in vet school, and it's either going to be true or false. She's either in vet school or not in vet school. So yes. The expression 12 minus 8 equal to 5, is that a simple statement? The answer is yes. It expresses the single idea that 12 minus 8 is equal to 5. That statement is either true or false. Again, it's not about being true or false. We can determine if it's true or false. History is interesting. Is that a simple statement? No. History is interesting is an opinion. This is an opinion. I might think it's interesting. You might not think it's interesting. Who will win the student government presidency? This is no. This is not a simple statement. This is a question. Go to your room. No, this is a command. This is not a simple statement. Alex is taking a math class and Sue is taking an English class. Is this a simple statement? The answer to this is no. Both statements individually are simple statements, but a simple statement expresses a single idea. We have two ideas going on here. So, no. Quantified statements involve terms such as all, each, every, no, none, some, there exists, and at least one. They're expressing the concept of an amount. They don't tell you in particular the amount, but it is a quantifier term involved. While all, each, every, no, none are quite clear in the amount, all means everything, each, every one, every one, no, none, none, right? So these are quite clear in the amount, but the word some, there exists, is not so clear what is meant, because some could be one, it could be two, could be 3, 4, 5, etc. It could be all of them. Well, this is what you should do. You should identify these as meaning at least one. You're going to be working, as we will see, that we should kind of think of some as being one. There exists, meaning at least one, so identify it with one. We want to identify the quantifiers in the following statements. All dogs went in the water and none of the cats got wet. Where are our quantifiers? Our quantifiers are all and none. Some people like to have pickles for breakfast. Our quantifiers are just one of them, some. A few students passed the class. The quantifier is few. The negation of a statement is the corresponding statement whose truth value will always be opposite of that of the given statement. In other words, if they're negations, when one's true, the other's false, and when this one's false, the other one's true. Which of the following would you consider each statement to be a negation of the other? Pause the video again as we work these problems and give them a try. I went to the park. I did not go to the park. Negations? Well, if I do go to the park, this is true, and so this one's false. If I don't go to the park, then this one's false, and this one's true. So their truth values are always opposite of one another, so yes. Next one. The house is not on fire. The house is on fire. Negations? Just like the one above, yes. Because when the house is not on fire, this is true, but then this one's false. When this one's false, it's the case the house is on fire, so it's true, opposite truth values. The house is red, the house is blue. Negations? Well, let's see. Suppose the house is red. Well, then the house is not blue. Now suppose the house is not red. Is the house blue? We don't know. It could be yellow. It could be green. So the answer to this one is no. It could be the case they are both false. All houses are red. No house is red. Negations of one another. Now here we have quantifiers. We have to be very careful here. Suppose all of the houses are red. Then it's quite evident that this is a false statement. Now, suppose this is a false statement that all houses are not necessarily red. Then, if we look at it, here's all the houses that are red. Suppose we have one red one, and it's false that they're all red, so we must have at least one that is not red, right? To get rid of all, you just need to move one. So once we move one house outside the red houses, this becomes a false statement. Now, none of the houses are red. I still have a red house, so we don't know. It could be the case that they could both be false. When you're trying to get rid of the word all, think about it. You only have to get rid of one. So the negation should have something with the term something like some. Some houses are not red. That would actually be the negation. Some dogs bark. No dog barks. Well, some dogs bark is true. Then this one's obviously false. But suppose some dogs bark is false. Well, some means one. If you get rid of that one, that means none. And that would be true, so the answer to that one is yes. So keep in mind, you got to be careful with the quantifiers. The negation of all are, some are not. The negation of some are, none are. When working with all, think about getting rid of just one of them. With working with some, again, some means if you're going to negate it, you're getting rid of just that one, and it has to go to no. But it's always in the context of the problem, so be careful. Writing statements in symbolic form. In mathematics, in order to generalize properties, we often express concepts in the form of symbols. This allows us to not have to focus on the specifics of a problem. When we generalize ideas, it allows us to prove rules, laws, properties, independent of the particulars of the given problem. What I'm saying is, I really don't care if the dog is red, the house is on fire, I went to the park, I didn't go to the store. All of that's immaterial to a mathematician. We want to get things in symbolic form. So, instead of focusing on if the dog barks, then I run is true or false, we're going to generalize properties of the if-then statement, which will then apply to any if-then statement, and likewise for the other connectives. Just hold on and you're going to see. Here are some rules that we're going to be following. We're going to be representing our statements such as this using symbols. So 1, simple statements are represented by lowercase letters such as P, Q, and R. So simple statements like the dog barks, I run, will get represented by lowercase letters. For example, if P represents the dog is blue, if a simple statement contains a negation like no or not, you actually represent the opposite statement with a lowercase letter. So we don't associate statements containing negations, simple statements containing negations with a letter. We actually represent it with the opposite lowercase letter. We're going to see that in a little while. So, for example, the dog does not bark. We would actually represent the dog barks using a lowercase letter like Q. So, the dog does not bark would be represented using the negation symbol and would write not Q. So again, the dog does not bark contains a negation. We represent the opposite statement, really the negation of that statement, with Q. And so therefore the statement containing the negation is represented by not Q. Now properties are going to continue on the next page. For the connectives, we represent and using this symbol right here. In other words, for example, I went to the park and I sang a song could be represented by P and Q. Assign P to this simple statement, Q to this simple statement. Our connective is and, represented by that symbol. We represent the word or using this symbol. I went to the park or I saw a movie. So here's a simple statement. Here's a simple statement. They don't contain any negations. They're joined together with or. We could represent this by P or Q. We represent the if-then statement using the arrow. Using the arrow, we can write the sentence, if the dog barked, then I ran. It could be represented by, well, the dog barked is one simple statement. I ran is another simple statement. Assigning them letters, we get P, then Q. Finally, the if and only if connective. It's represented by this bidirectional symbol. So the dog barked if and only if I cried could be represented by, well, the dog barked, I cried, if and only if, double arrow, and that's how we could actually represent that statement. So you need to know that this means and, or, if then, and if and only if. You need to be able to recognize those symbols. Using the appropriate symbols, convert the following to symbolic form. Note, I'm going to be working with the letters P, Q, and OR. So you should pause the video. You should try to express the statement in symbolic form. First one. I went to the park and I did not sing a song. I have two simple statements. I went to the park. I did not sing a song. I'm going to represent the first one with P. The second one contains a negation, so actually I'm representing Q with, Q represents the statement I did sing a song. And they're connected by and therefore this is my representation of that statement. The next one, the dog is blue if and only if the cat is red. I find two simple statements in here. The dog is blue, the cat is red. I'm going to assign P to the first one, Q to the second one. My connective is if and only if, the double arrow. So therefore, there's my representation of this statement. Third one, if the dog is not blue, then the cat is not red. Once again, the dog is not blue is a simple statement. The cat is not red is a simple statement. Both of them contain negation, so I'm actually going to represent this one and this one accordingly. So P would actually be representing the dog is blue. Q would actually represent the cat is red. It's an if-then statement, so I join them together with the one directional arrow, and we have not P, then not Q. Finally, it is not the case the dog is blue or the cat is red. Now you always have to take into account your punctuation, your wording, that's English, grammar skills, right? So, it is not the case, that's a negation of everything that follows because we have a comma here, right? Well, the dog is blue, I'm going to represent by P. The word or is this symbol here, and then we're going to let Q represent the cat is red. So our statement looks like this. It is not the case, parentheses, P or Q. When you have commas, commas are separators, right? Keep that in mind. Now let's take a look at several problems that are similar to the ones you may find in ALEKS. For each of the statements, determine whether or not, sentence, determine whether or not it is a simple statement. Bye-bye. Bye-bye is neither true or false, so it is not a simple statement. 8 times 5 equal to 40 expresses a single idea. It is true or it's false, so yes. Is your house painted blue? That's a question. No. The moon is the smallest planet. That I would consider yes. Now, the moon is the smallest planet. Well, since you're considering smallest in terms of a true measurement, you could line up all the planets, but the moon isn't even a planet, so again, it would be either true or false. But The word smallest in this context would be you could compare the sizes of each planet and say this is the smallest one. Turn off the TV. That's a command, so that is not a simple statement. Again, you should be pausing the video, trying the problems before I start explaining them. We want to determine which one or which ones of the following would be a negation of this statement here. Keith is not wearing boots. Keith is not wearing boots. Okay, well, is Keith wearing a wristband the negation? The answer to that is no. Because if Keith is not wearing boots, we have no idea if he's wearing a wristband or not. It has nothing to do with our problem, our statement, right? It is not the case that Keith is wearing boots. It is not the case that Keith is wearing boots. In other words, Keith is not wearing boots. Well, that's the same thing as what we're saying above, right? Saying the same thing. So it can't be a negation. Keith is wearing tennis shoes. Well, again, wearing boots, not wearing boots has nothing to do with wearing tennis shoes. So, no. Keith is wearing boots. Well, that is the opposite of Keith not wearing boots, right? It is not the case that Keith is wearing sandals. Once again, wearing boots, wearing sandals are two different things. And so, whatever's going on with the boots, we have no idea about the sandals. So the answer to that one is no. For each statement, choose if it is simple or compound, and if compound, what type of compound. The crew will paint the house blue or green. There are two ideas here. The crew is going to paint the house blue, or the crew is going to paint the house green. So it's compound. It contains the word or, and so or is associated or identified with the word disjunction. My favorite game is truth or dare. That's a simple statement because the word or is part of a name, a title of a game, so it's a simple statement. One idea. Jessica will win the race if and only if she runs faster than everyone else. Jessica will win the race if and only if she runs faster than everyone else. That is a compound statement. It contains an if and only if, which is the biconditional. Consider statements P and Q where P is identified with it is Monday, Q is identified the students are in the gym, and we want to answer the following statements or questions. For A, we want to express the statement in symbolic form. It is Monday and there are students in the gym. So it is Monday is associated with P, the students in the gym, Q, they join together with the conjunction and, so P and Q. Part B, it is Monday or there are students in the gym. Likewise, the only difference is P or Q. Now, we are given the symbolic form here on the right side. Given the symbolic form here on the right side, we're saying negation of Q, there are students in the gym, there are no students in the gym. Consider the two statements. P, it is summer. Q, Rita is wearing shorts. Answer the following three questions. We want to write the first one in symbolic form. Rita is not wearing shorts. Would be represented by not Q. It's joined with an or. It is not summer, represented by not P. So here it is, not Q or not P. For B, it is false that Rita is wearing shorts or it is summer. It is false that's a negation of the entire statement, so we need parentheses. Rita is wearing shorts is Q, connected by or to it is summer, which is P, so here is our statement in symbolic form, not Q or P. Look at the significance of the parentheses. Finally, we want to take this statement and express it in its descriptive form. So, not P, it is not summer, and Rita is wearing shorts. It is not summer, and Rita is wearing shorts is the first one. If we let P represent we sell beans at the market and Q represent we sell apples at the market, then we can express this statement here in symbolic form as follows. We sell apples at the market is Q. We sell beans at the market is P. They're joined together with the if then Q, then P. Over here on the right hand side, we're given a symbolic statement. What's its descriptive form? Not P would be we don't sell beans at the market. If and only if we don't sell apples at the market. So negation of P, we do not sell beans at the market. If and only if we do not sell apples at the market, it's the first one. Representing P by we have sushi for dinner and Q by it is Sunday. We're doing the same thing here. We want to take a descriptive form, write symbolic form. We are not having sushi for dinner is the negation of P. We're joined with and to the simple statement it is not Saturday, not Q. For B, it is Saturday, but we are not having sushi for dinner. It is Saturday, but we're not having sushi for dinner. So we know it's Saturday, but we're not having sushi for dinner, and we are not having sushi for dinner. So Q and not P. Gotta be careful of the wording of this stuff. It's English. On the right hand side, we have it is not the case that we're having sushi for dinner or it is Saturday. It is not true. That's the way he wrote it. It is not true that we're having sushi for dinner or it is Saturday. Two more things. If P represents there are monkeys at the zoo and Q represents there are tigers at the zoo, then the descriptive form of this statement here in A can be expressed in symbolic form as the following. There are monkeys at the zoo, which is P. There are no tigers at the zoo, which would be not Q. Our connective is the if and only if, which is the double arrow. For the second part, we're given the symbolic form. Now we need to describe it. It's an if-then statement. Well, we have two of them, so it's between the first two. It is not the case tigers are at the zoo. There are no tigers at the zoo. So if there are no tigers at the zoo, then there must be monkeys at the zoo, right? If there are no tigers at the zoo, then there are no monkeys. No, there are monkeys at the zoo, so it's the second one. Letting P represent it is fall. Q represent we are going riding. Our descriptive form, we are not going riding only if it is fall. Only if it is fall. Well, this is a tricky one because it's an if statement. Because if we don't go riding, it has to be fall. Because the word only. So, if we are not going riding, it must be fall. For B, it is not fall if and only if we are not going riding. So it is not fall, not P. We are not going riding, not Q. Joined together with the if and only if, not P, if and only if, not Q. Next, take our symbolic form. express it in words. Q is we are going riding. If and only if it is not fall. We are going riding if and only if it is not fall, the last one. And so this ends the section 3.1 video. I hope it helps. Thank you.